Hello everyone. So today let's work with another problem of microwave spectroscopy. That is problem number 2. It says that the microwave spectrum of gaseous HCl molecule exhibits a series of equally spaced lines with interspacing of 20.7 centimeter inverse. Okay, so again here also the interspacing is given. That means the distance between the two lines of the spectrum is given to you as 20.7 centimeter inverse. Calculate the internuclear distance of HCl molecule. This problem is somewhere or the other correlated to the one that we did in our previous video. So let's try and check out how much we have gained in the previous video. Okay, so the formula that is supposed to be used for this problem is I, that is moment of inertia, is equal to h over 8 pi square b into c. Okay, and since the interspacing is given to us, so that means 2b is given to us, which is equal to 20.7 centimeter inverse. Okay, so when 2b is equal to 20.7, so therefore b is equal to 20.7 over 2, which comes out to be 10.35 centimeter inverse. Okay, fine. Or it can be written as 0.1035 into 10 raised to the power of 2 meter inverse. Okay, now let's come back to our original expression, that is expression number 1, and now we simply substitute the values. Okay, so I is equal to h, that means 6.625 times 10 raised to the power of minus 34. Okay, fine, divided by 8 times pi square, that means 3.14 square, times the value of b, that is 0.1035 times 10 raised to the power of plus 2. Now since we have taken meter inverse over here, so I don't need to change the unit of this speed of light, so it will remain as it is, 3 into 10 raised to the power of 8 meter per second. Okay, so let's calculate the value of I from here. It comes out to be 270.5 times 10 raised to the power of minus 47 kilogram meter square. Okay, moment of inertia we have obtained from here, and we very well know that the internuclear distance, the r, which the problem is asking us, actually is related to moment of inertia and the reduced mass. Okay, so that means in order to calculate the value of r, I need to have the value of reduced mass also. Okay, so let's go with the second half part. That means I just calculate the value of reduced mass, which is equal to m1 times m2 divided by m1 plus m2 into the Avogadro number. And m1 and m2 are the hydrogen and chlorine respectively. So their respective masses are 1 and 35.5. So I simply substitute these values and I'll try to get the value of reduced mass. The Avogadro number is 6.023 into 10 raised to the power 23. So the reduced mass comes out to be 1.614 times 10 raised to the power minus 27 kilograms. Okay, now I'll substitute the value of I and the value of mu in the expression, final expression. Okay, so R is equal to under root of moment of inertia, that is 270.5 times 10 raised to the power minus 47 divided by the reduced mass, that is 1.614 times 10 raised to the power minus 20 seconds. So now since the units are also matching with each other, so I don't need to do any extra conversion over here, and simply by calculating the square root I get 12.9 into 10 raised to the power of minus 10 meters. Okay, so this is the value of my internuclear distance or the value of R. It's just based on the same pattern as we did our previous problem also. So now you can solve more problems taking into consideration of these numericals.